Section 3.1 is on parallel lines and transversals. Parallel lines are coplanar lines that do not intersect each other. So in this picture right here, lines L and M are parallel to each other. When we're writing it out, L and M, we use two vertical parallel lines to symbolize parallel. When you're drawing these, make sure they're kind of close together and maybe a little bit taller so it doesn't look like an 11. On the diagram, we use these little triangles, one on each line, to show that these lines are indeed parallel. Skew lines are non-coplanar lines that do not intersect. So for example, AB, the pink line, and CD are skew. So you can see, even though it looks like they might intersect, you need to picture this cube in 3 dimensions. AB is the top front, across the top front of the cube, and CD is a vertical line on the back right-hand side. So even though those lines continue on, they will never intersect each other. So they do not lie in the same plane, and they will not intersect each other. Parallel planes are planes that do not intersect each other. An example of this would be the floor and the ceiling of a room. Those are two separate planes, and they will never intersect each other. So let's take a look at an example here. Given this cube with all of the vertices labeled, identify each of the following. Number 1, all segments that are parallel to segment EF. So segment EF is the front top of the box. Actually, if you're having a hard time picturing this cube in 3 dimensions, you might want to get your hands on a one of those cubic shaped Kleenex boxes. That might help you to visualize it a little bit better. So all the segments that are parallel to EF would be AB across the bottom, GH across the back, or you can call it HG, either way, and then segment CD across the back on the bottom. Those are all parallel to EF. Now how about all segments that are skew to GC? You might want to think of this as any segments that are not parallel to GC and that do not intersect GC. So one of those would be AB across the front here. Another would be AD across the back, the left side on the bottom. Another one is EH, which is directly above AD. And segment EF, which is directly above AB. And then how about all planes that are parallel to plane EHD? Remember that to name a plane, all we need are 3 non-collinear points. So plane EHD, notice that point A is also a part of that plane, but I only need to use 3 of those letters. So that is the left side of this box. So the only other plane that is parallel to this one is the one on the right side over here. And to name that, I can use any 3 of those letters in any order. So I might say F, G, C. And that's the only plane that's parallel to it. A transversal. A transversal is a line that intersects 2 or more coplanar lines at 2 different points. So in this case, you have line L and line M, and T is considered your transversal. Notice that this transversal creates 8 angles, which I have numbered here. We call angles 3, 4, 5, and 6 interior angles because they lie between lines L and M. We call angles 1, 2, 7, and 8 exterior angles because they are on the outside of the 2 lines that are being cut by the transversal. And beyond that, we actually have some more special angle pairs that take this a little bit further. The first one is called alternate interior angles. And in this case, that would be angles 4 and 6 and 3 and 5. So alternate interior angles are on alternate sides of the transversal and on the interior between the 2 lines that are being cut. So 4 and 6 are alternate interiors, and another pair would be 3 and 5. They're on alternate sides of the transversal, and on the interior of the angles. Another special angle pair is alternate exterior angles. So like 1 and 8 and 2 and 7. These are on the exterior of the line, so across the top here and across the bottom, and as pairs they are on alternate sides of the transversal. So for example, angle 1 and angle 8 are a pair of alternate exteriors, and angle 2 and angle 7 are another pair of alternate exteriors. We also have consecutive interior angles. An example of this would be angles 4 and 5 and 3 and 6. They're interior because they're between the lines, and they're consecutive because they're right next to each other. They're not on opposite sides of the transversal. So 4 and 5, 3 and 6 are alternate interior angles. I'm sorry, consecutive interior angles. And the last angle pair is corresponding angles. These are on the same side of the transversal and are on the same side of the two lines that are being cut. So for example, angles 1 and 5 are a pair of corresponding angles because they're on the same side of the transversal T, and they are both above the lines that are being cut. 1 is on top of line L, 5 is on top of line M. Another pair of corresponding angles would be 2 and 6. Another way to look at it is they're kind of in the same position. 2 and 6 are both to the right of the transversal and above a line. 3 and 8 are another pair of corresponding, and 4 and 7 are another pair of corresponding angles. If you're a flashcard person, this would be a really good thing to put on a flashcard because you do need to know these angle pair names because we'll be using them in the next section. So let's take a look at an example here. Identify the transversal connecting each pair of angles, then classify the relationship between the angles. So if I'm going to look at angles 3 and 6, as I am doing in example number 1 here, 3 and 6. The transversal that creates that special relationship is the line L. So basically I need to ignore line M. S and T are my two lines being cut, and L is the transversal. And 3 and 6 are alternate interior angles. And we can abbreviate. Okay, let's take a look at angles 7 and 14. The relationship between 7 and 14. So it looks like in this case T is going to be my transversal. L and M are my lines being cut, and I need to ignore line S. So between 7 and 14, my transversal is the line T, and since they are both on the outside of the lines being cut and they are on opposite sides of the transversal, these are going to be alternate exterior angles. Example number 3, angles 1 and 9. 1 and 9 up here at the top. Those are being created by the transversal S. And 1 and 9 are both on the same side of S, and they are both, well, I guess in this case to the right of the lines. So those would be corresponding angles. And our last angle pair to take a look at is 12 and 14. And 12 and 14 are here, and the transversal that creates that special relationship is the line M. And since those are on the same side of the transversal and they're right next to each other, those are consecutive interior angles. So make sure you're aware of all of these different types of angles. Make flashcards if you need to. Go ahead and learn this vocabulary.